Hello everyone, this is Mainak and today we will design the roof truss of this particular building in Etabs software. So as you can see a little bit description of the building. So the building is a single story building here, and this is the elevation of the building here, and I've just changed the column positions here according to the roof truss position. So as you can see in this plan, the architect has given the roof shape. So you can see this is the shape here, roof. So according to that, I had adjusted the columns a little bit. Obviously, the size of the columns are not decided, but I've adjusted the size of the column, location of the columns a little bit. So one truss will go here, and another truss I'm planning to put here, and another truss I'm planning to put here. And I am going to place the purlins like this. So let me just show you. I have already completed the model here earlier. Just for showing you how the model will look like, so that will help. So the model will look like this. So as you can see, you will have roof here, and this slope will be matched like this. So the purpose of making this video is you can find many tutorials on the roof design, but how to just make the roof truss or make the roof truss system according to the architectural plan. So just this is a very simple one. Okay, we have more complicated ones as well. I'm planning to cover that also, how to model this. Mainly the main functionality is in the modeling, and also like if we just have to consider the practical aspects of how the roof sheets will be arranged. In this case, we're using a PPGL sheet. So you can have PPGL sheets of Tata or SRMB, or many good companies are there, but you can use simple tin sheets or PPGL sheets. So there are two types of sheets mainly, PPGL and PPGI. There's some difference, you can check this out. PPGL is the more advanced version, lighter and better. Okay, so this simple roof system design we will do. So let's go. So first of all, we'll just create a new model here, and we'll use the settings here. We'll use this particular settings, and grid lines we'll make, and also story data also it will be custom. Okay, so here if we just must have the AutoCAD file ready here. So we'll have the specification. So this is the X direction, this direction, this is the X direction in Etabs, and this is the Y direction in Etabs. So number of grids which we'll find in X direction as per the column location: 1, 2, 3 and 4 and 5. So 5 number of grids we'll need here. So you can add another grid here in the X direction: 1, 2, 3, 4, 5. Okay, so the first coordinate is 0, and the next coordinate is 4.06. okay, so just I can just type in the next one, 4.06. okay, and in the next one, this you can 4.06, whatever this is, plus 5.240. okay, so just type equals to 4.06 plus 5.240, and we'll have this result here. And then the next one is 5.5, next to that is 5.5, so is equals to 9.3 plus 5.5, so is equal, and then the last but not the least, last one grid distance is at 3.8. so this is pretty simple. Just don't worry about plus 3.8. so we get this grids in the X direction. Now in the Y direction, so you got to notice the figure that if you are not able to see also, this one starts from here. So this is 1, this is 2, this is 3, and this is 4. So it starts from the bottom. So you have to figure this out like this. Okay, so the first grid is 0. So number of grids, okay, first let's decide: 1, 2, 3 and 4. So 1, 2, 3, 4 are there already, so no problems in that. So first is 0, second is 2.4. so second is Y coordinate 2.4, and then we'll have here already calculated this. So this is 6 total we have calculated this time. Okay, or else you can just add this also like the previous one. Okay, if you add this 2 also, that will come at 6. okay, 6 meters for the next one, 6, and then the next one is 10.5. So it's in that taken from the origin, so that's why you don't need to add here. So these are the grids here for the columns. So click on OK simply. So this is done, and now the story data. So we don't need this many stories here. Right click and delete story, delete existing structure story. Okay, 0 and 1. So what is the height of the truss which you are having here? So we are deciding the height of the truss. So the height of the truss here is we should find from the architectural plan here. So this is 2.1 meter. So just insert here 2.1 meter. Okay, so 2.1 and click on OK. So story grid, custom grid spacing done and story data done, and click on OK. So your model is ready till now. So when this window opens, the first thing which we are going to do is going to define the material properties. We're going to add new material. Obviously we're going to go for India and then steel and then Fe250. This is the grade which you're going to use because this is the most only used grade. If you want to add higher grades, you can do very easily. Just click on OK, and we'll add another new material here, and let's add concrete. But the concrete will not be used, but let's add it anyway, just for showing M25 grade of concrete. Just add it simply, and again check the material properties. Sometimes if you don't click on OK directly, if you just click outside, then this doesn't save, so get saved. So make sure you have this saved as well. Okay, so okay, so cancel this now. So next thing which I'm going to do is we're going to define some frame properties here. So here we're going to import new properties. Firstly we're going to for the steel, we're going to go here steel here, and then we're going to go select angle sections for our first select India, and then select the grade of the steel Fe250, and then we'll first of all select some angle sections, steel angle sections. So we'll go with ISA 100 into for the bottom part. So we'll go to with 110 into 110 into 10 for the bottom chord of the truss. If you don't know what is bottom chord, top chord, I'll just show you, don't worry about that. Okay, and another one, let's import here here Indian Fe250, and just go with angle sections here. And for the internal members, let's go with ISA 50 into 50 into 6, this one. 15 to 15 to 5 also will do. Okay, and then in the property here, this one for the top and bottom chord, this is okay. And for we'll have this rectangular section here, steel tube. Okay, so we'll use ISB 72 into 72 into 4. This will be for the purlins and bracings and whatnot. Okay, so these three properties should be okay for now. If this is not passing, then we'll see what to do. Okay, so this is good, and now we'll just select this, and we'll select the beam property here, the property which you've just created for the bottom chord, because this is a plan, so this will be the bottom chord here. So we'll use 110 to 10 for the bottom chord here. So this is at 2.1, this is 0, so obviously we'll be doing the work at 0 here. So A number grade, bottom chord. Okay, done. Right click outside, and this grid, bottom chord, right click outside. So this will make the form the part here that will be running for the truss. And now in this part, what we'll do, we'll divide this. Okay, so edit frames and divide frames. So divide frames into 2, apply and OK. So frame is divided into 2, and then we can open the elevation because this will be helpful. So this is grid number B. So click here first, elevation and grid number B, and click on apply and OK. Okay, done, good. And then we'll select this one. This one is for the internal members, right, and also for the top chord also. So here let me just use the internal member property which I'm planning to use, as 15 to 15 to 5. Select this and just go above. Just make sure this angle which comes here greater than, it should be 90. Don't worry about meeting at perfect time, 90. Right click to end this command, and again just select the bottom chord and top chord command here, top chord property, sorry, not command. We'll select this, and we'll select, you can see this selection is not working now. So for that we have a solution. So select this like this, okay, and here we'll go edit, and edit frames, divide frames, and we'll use break at intersection with visible grid line. So this is a visible grid line, so at this point it will break. Apply and OK. So let's check. Break, delete. Now we'll select the beam property for the, this is the ISA 110 into 110 110 for the 110 into 110 into 10 for the top and bottom chord. Select this here and join this here, right click and end this. We don't want any support set here. Click on escape and click on assign joint restraints. No restraint or support here, okay. But designing such that all the supports are forces are at the end, and here we are not taking as fixed because we don't want any moment. This will be applied on the top of this structure, so it not taking a fixed connection, okay. So now by the way, if you think anything is technically wrong, you can just let me know in the comments with the appropriate reason, and happy to learn and improve for all of you guys. Okay, so now select this and go to edit and go to edit frames, and we divide this. So we have to decide now how many members we'll put here. So let's see what the architect has planned here. So architect has actually divided this into 1 2 3 4 and 5. I think 5 is max, too much, so I'll go with 4 divisions. So, and I will end up with 3 members here. So we'll go to edit frames and divide frames, and divide into 3 parts, sorry 4 parts, then we'll have 3 vertical members, okay. So again we'll just delete this later. I can delete this later also, okay. Let it be for now. So internal member property we are planning to have 15 to 50 to 5. Same thing, just make sure you have the joint selected and you have the angle at 90 degree. Don't worry about the other things. Right click to get out of the command, select this, get 90 degrees, select left click and then right click, select this, left click, get 90 degree and left click and right click, okay. Click on escape now, and then select this and select this. Now we'll go to edit and we'll go to edit frames and divide frames. Now this time we'll use this option, intersection with selected frames. So at this intersection it will break, okay. So we are being able to select this and delete this. While selecting, you don't need to click on control, because in Etabs and AutoCAD you don't need to do that, okay. So here, before joining this, let us just take this option, internal members, okay, and this is like this. This is Harvey Truss, I think. So this is Harvey Truss. We'll go like this, right click, like this, right click, and like this, right click, and now I think we can join this. It will be better for the in the future of the model, and we can join this also, the bottom chord also. You can join it into a singular thing. So edit frames, join frames, and just click to check. This is a single member now, and this is also a single member now. So here this is I think the job is done. Now I think I can remove these supports here, assign joint restraints, and then no restraints, apply and OK. So these are done here, and this is done, this is done, and this is done. So this is selected, okay. Now we want to mirror this on the other side. So we have an option here, mirror, and pick 2 points in model. So if you use this and this, and if you click on apply, you can see nothing here. Before click on apply, you can see nothing. This doesn't work like this, okay. In this plane it doesn't work. So how it will work, let me show you, okay. So here, okay, so here let us select this, and also let us select the yeah, actually we can join this also, no problem. Edit and edit frames, join this also. Okay, no problem. So you can select this at once. So this is selected. So go to Control plus R, shortcut of replicate, and linear. We'll pick 2 points in model. Move this a little bit. Select this and select this. Click on apply and click on OK. Now since I've joined, there is not a center here. So and this is also this both of these don't have center here. So we go to edit, edit frames, divide frames into 2 parts. So now both have center. Okay, so now we'll select the internal members here from the elevation. Done. Control plus R for replicate, mirror, pick 2 points in model. So just hover over to apply. If you see, don't see this, then there is something wrong. Okay, so we'll just check again. These are the 2 points here. Let me just check once again, and Ctrl plus R, mirror, pick 2 points on model, this and this, hover over to apply. It's not showing. Let's see what happens. Yeah, it is. Okay, click on OK. For some reason it is not showing when I was going over to apply. Okay, I think this window is selected, that's why it is not showing. I should have selected this window, my bad. Okay, so okay, this thing is done. Mirror has been done successfully, and now I think we can join this again. Okay, edit frames and join them. Okay, the entirety of this thing is done here, and now we can delete this and we can select this entirely, and like this also. Let's select, and then we can go to edit and replicate, or just press Ctrl plus R to replicate. Linear, pick 2 points in model, select this, apply, and again select this, escape and select this again, pick 2 points in model from here to here, click on apply. Okay, so let's check the 3D view here. So this is the 3D view of the truss here, which you are finding. So here let us put another bottom chord member, ISA 110 into 110 into this. Okay, this is done, and now let us work on the purlins here. So purlins will be in this property, the simple rectangular hollow box. So I like working on the plan in the purlins here. There is also other ways also. Right click. Oh, I messed up. Ctrl plus Z. Right click to escape from the command. Just go above, and here now you have this joints readily available. So from this joint to this joint. Okay, just make this physically from here, from this joint to this joint, this to this. Right click, this to this. I think I should break this, delete this and break this at where it is required. There is an option in extrude also. Using that also you can do. I'll just I think I'll show one of them using that option. Just for if you have a truss which has uniform spacing, then that option is by using that option it is better. Okay, right click, left click, right click, left click to escape from this. We could mirror, but anyway, it's not that much, so we'll continue. By the way, you can use shift and your mouse. Oh, I messed up again. Ctrl+Z, shift and mouse middle button to like rotate this model. It's similar to SketchUp, the rotation part, and also AutoCAD 3D. Right click to escape from the command, like this. Okay, and now if you want to add bracings here, let's add some bracings. Let's go right click, right click, click. This is where the sloping roof will meet. So you want to divide this two frames, to select this two, go to edit and go to edit frames, divide frames at 2 points, just to have a, remove this, assign joint restraints, and then we'll do connect this and also connect this. Okay, so once this is done, we'll do similar things. Select this, select this, and select this. This you can deselect, shift and select this to deselect, and only these three things, 1, 2 and 3. So you can divide this into 4 parts. Edit frames, divide frames, 4 parts, apply and okay. Just take the purlin from here, so it will be approximately in the bottom part locations. So that's how we figure the joints out. Similarly, so this takes a bit of patience, and also in every different kind of models, so you need to have some innovative ideas to solve the things. So that's why the knowledge of how the things are executed at site is also important for a structural designer, structural engineer. So if you have this knowledge of how the things are executed at site, and it's better. If you don't have, you can consult a friend who is experienced in all these things, seen them, what the design will look like, and then you can have an idea of the structure. Because these particular topics, videos maybe you'll find on steel truss and all, but these particular shapes and all how to model this, how to design this. These things are rare, and this kind of things challenges you face. So I need to solve this using some practical experience. So that's what I'm trying to do. Okay, so after having done that, simply go to slab properties. We will not define the slab properties here. So basically I've seen that the maximum amount of load which can become on a PPGL sheet is less than 0.1 kilonewton per meter square. So I'll apply dead load of 0.33 here and live load of 0.75 here as per IS 175 part 2, table number 2, not table number 1. Okay, so I'll not go into the details of that, it will be a long video. So that's why just we'll have a simple slab section here. So let's go here, section properties, slab sections here. Simple, go with any material, it doesn't matter. I'll go with PPGL sheet here, and I'll just give a very small thickness, just that the weight of the concrete doesn't matter here, and obviously do membrane because we don't want to take the moment here. Okay, this will be simple, like simple PPGL sheet here, so no moment here. So click on OK, and then we have to model the floor. PPGL sheet, make sure this property is selected which you have just made here. Okay, then rotate this. Okay, so you have shortcuts for this also. You can also extrude this from the from the frame. I think I had done using that method in the previous video, so you have that method as well. So we'll just do this like this here. Okay, so this is done. So we'll do this like this here, and after this is completed, we will assign the loads. So first of all, we go to define and we'll go to load patterns. So we'll add a new load pattern here. We'll call it other dead, and self weight multiplier not needed in that. Okay, and we'll add this other dead load, and we'll add a wind load in one direction, and we'll just keep the wind load code here. And obviously 2015 is the latest Indian code, when one, and this one will do for the windward side and maybe another one for the leeward side. Okay, so just double click on this modify lateral load. 55 is the basic wind speed of Agartala, Tripura, where this is being made. Terrain category 1 is the worst terrain category, means maximum amount of wind load will come. Open terrain categories, you can check out the code. We use shell, so we'll use exposure from shell objects and directly assign the wind coefficients here. Remaining things are okay, and similarly same thing we'll do for this also. 55 1 and shell objects. Okay, click on OK to save this. So first of all, let's select all these shell objects. So we'll go to select by object type, should do floors, select. No, floors will not select this. This is okay. Let's go select by properties, slab sections, PPGL sheet, slab. Okay, then assign shell loads here, uniform. For the dead load, we'll select 0.33, maximum amount of load which can act here in the gravity direction. Apply, and go to select and get previous selection, and then select the live load, and live load will go 0.75, and then click on apply. Then click on Okay, so these two loads are done. Now we'll use the wind load. So let's apply the wind load in two directions. Suppose in this direction, this is the if this wind acts in the windward direction here, one. Okay. So wind 1, so let's let W1 go windward load here, and then we'll have a leeward side in the other phase. So we'll go to assign shell loads, wind pressure coefficient W1. Maximum coefficient is on the conservative side, the maximum more conservative side. So you can just take CP1, otherwise you need to calculate in detail. So let's take the CP1 more on the conservative side, windward side. Let's take this as the windward side and click on apply, and in same W1 let's take this as the leeward side. Select this carefully so that internal members are not selected, and leeward side, and click on apply, and okay. So you can see in W1 those two types of loads are selected. Let's go to W2 here, and first of all go to windward and select this 3 once again, and okay, no, W3 will go this one windward. Okay, this one will go windward, 1 2 and 3. This one will go windward 1. Okay, this one is not selected or selected. Yeah, okay, this one will go windward 1, apply, and for the leeward we'll select this leeward 1, click on apply. Okay, so here we can do like this and click on OK for the wind load applications, and then we will define the load combinations, add new combo, rather just add default load combination steel frame design. That's what we're going to do, and we're going to click on analyze, and then after the analysis is complete, we'll just quickly move our mouse over to this portion because this is steel frame design. After this is the analysis is done, we'll just click here for the steel frame design here. Let's go click here for the steel frame design. Yeah, so this design is done, and if there is any member which is failing, you can also check here. Just select this, verify all members passed. 8 members have failed shear capacity checks. Do you want to select them? Yes, we want to select them. Okay, in here also just verify all members passed. In this members also select this. In this view also I want. So you can see bottom chord members, there is no member failing. The top members also, there are no member failing. So which members are failing here? So some of the purlins are failing here basically. So all the purlins which are failing, they already selected here. So we'll just assign new property to them. So we'll just unlock the model here, and you can see these purlins are failing here. Okay, apart from the purlins, we have the other things also. So first of all, let me select this and this as well, and select this and this as well. So is this selected or not selected? I don't know. Shift and this. Oh no, it was not selected. It was not selected. Okay, so these members, yeah, this also need to be selected if this is. Just for symmetry. Okay. These, okay, 1 2 and 3 4, mainly these members. So first of all, let me just edit, and you want to join this? No, just go to assign frames, section property, and we'll use a different section here. Modify, import new property, box section. So I'll use 132 into 132 into 4. Let's see here, 72 to 72 into so there is 113 into 113 into So we used previously this 172 into 72 into 4. So here we have other properties here, 132 into 132 into, let's use this, and if this doesn't work then we'll use the higher sections here. Okay, let's use this. Okay, and apply, and okay, and then analyze once again, and design, and then check all still members have passed. So you can see the design is complete. So if you want to see the 3D view, it's better you see without this slab portion. So just select this, go to display undeformed shape, and you just can see the 3D view like this. Okay, this is with this software sometimes glitches out because the purlins will be inside. So if you want to stay without the slab, then you can see, and go to select, and select by properties, and slab sections. Obviously one section you have select, and then after selecting this, and right click and hide selected objects. So this is the view which you want, which I had shown at the starting of the video here. So you can just have this view, and this is the design. So, and if you want the reports of it, because in government project submit the reports, you can just show summary report, and or show project report, and submit the report here. Just for saving the report here, you can just save this report directly, or you can just we'll just open a new page here, add new window, and in this particular window you just to the file, create report, show summary report here. Why is it coming in here? I want it here in a larger view. Okay, then you can export it to Word, or you can print directly, print to PDF, and then you can print, and then you can export. So like this you can do. Okay, so let me just save this, print to PDF. Okay, and just I'll say in the desktop here, truss roof, truss design report. Okay, and then click on save. So this is saved, and you can open this PDF here, and you can check this design out. Okay, so you'll have all the things which are available here, base reactions and all. You can check all the things here. You can also submit this report. Etabs is a very trustable software, so you can use this report in your file. So that's how we make this. Make sure to learn properly, revise, and don't forget to like the video and also share the video. Okay, thank you. Bye bye.